So we are going to attempt to solve this initial value problem where the forcing function is a Dirac delta function. And what I'm doing is that instead of these notations, I'm using this notation because it's easier to write and takes shorter just for me. All right. So let's just go ahead. First, let me erase the highlights here. And then, so I'll erase these, and also to save space, what I would do is this, that let me get rid of this here. Okay. So now we will use the method of Laplace transform. That is, we'll apply the Laplace transform on this entire equation and then just use the linearity of the Laplace transform. That is, we have, as I said, we will apply that. And remember this, that we had already obtained that the Laplace transform of the first derivative is the Laplace transform of the original function, all right, and minus the initial value of the original function. And we can just use this because this is not hard to keep in mind. At the same time, it will be printed for you on the exam, but this would not be, but you can derive it like this. That is, we are going to find or write the Laplace transform of the second derivative. So what we have is that we are going to take this as our function, and now we are going to write Laplace transform of derivative of this function just by using this equation. So what happens here is this, that is, first of all, here instead of y, what we have is dy dt, because that's what your input function here will be, and here it will be dy dt, and I'm just changing dy dt to y prime 0 here. And then all that we have to do is this, that we just have to fill in this value for the Laplace transform of the derivative. So that's what we get, and it's going outside our recording area. So what I will do is I'm just going to copy and paste this in the second line, and then just erase the middle portion here. So one moment, we got this, and so this is the Laplace transform of the second derivative, and we know our y0 is how much? 0. So we can just write these values down here. So just open the parentheses. Here we get, don't know why I'm in such a hurry. Okay, so this is square, and y0 is 0. Okay, and then y prime at 0 is 2 right here. So that becomes a 2. Okay, and we had also seen that the Laplace transform of this Dirac delta function is how much? E to the negative is, and then for the second forcing function where we have this as 2 pi, so here we have e to the negative 2 pi s. So now we will just substitute these values in this equation that we obtained by applying the Laplace transform. So the Laplace transform of the second derivative is right here. Now let's get the Laplace transform of the first derivative, and remember y at 0 is 0. So this will simply be how much? S times Laplace transform of y. So now what we can do is that we can replace the Laplace transform of dy dt by s times Laplace transform of y, and these will be replaced by who? Their respective values, right? So there we got e to the negative 2s. So what we will do now is we are going to now solve for what? Ly, and then we are going to take the inverse Laplace transform. So first thing we will do, just like we are working on algebra 2, that is we have to solve for Ly. So let's just put everything else on the other side. So we got this, and then we are going to factor the ly out. Okay, so let's do that. So this is going to be factored out. So out, and out, and then what we get here is that has been factored out to this. So what we got eventually is that this is the Laplace transform of y. All right, and now all that we have to do now is to obtain the value of y. Okay, so we got this, and I am just to save time, I'm just doing this here. That is just working on it by copying pasting. Okay, because I hope you are following what we're doing here. And then here on the top we will have only 2. Okay, so what y will be, again, the inverse Laplace transform is going to satisfy the linear property. So you will have L inverse, L inverse of, or Laplace inverse of this, okay, and then plus, let me just do this here, okay, that is Laplace inverse of, here this changes to -2, okay, and here all that we have is 2. So we are going to compute or calculate all these inverse Laplace transform, and what I will do is that we are just going to look at the table that we are provided with. All right, so let's go to the table, identify these transform values, and write the inverses according to the same. Okay, here is our table. Okay, and if we look at the table, then you can just scroll down, and first we are going to look at the simplest format, that is this 2 over s squared plus s plus 5. So if we look for that, then notice this, that here we have a quadratic. All right, so we have a quadratic here, but right here we got a second degree term, and then a first degree term. So what it comes closest to is this one, right? Okay, because if you see it, here we have to do or work with a technique what you called completing the square, where you have, when you have s squared plus 4s plus 5, you have s squared, then you take half of the coefficient of s, that is 2, square it and add it here. Now this 5 then can be broken into 4 plus 1. So this portion would be what? S plus 2 quantity square plus 1. So what we get now is that this portion here, or what we got is 2 over s plus 2 quantity square plus 1, which is 1 square again. And if you compare here, then in this portion, the quantity A is going to be how much? -2. Okay, and omega square is 1, or W, I can call it W as well. So I can do this, that factor this 2 out here and write that as 1. So what that will become in this manner is this, that its inverse Laplace transform will be e to the power, okay, and remember our a is -2, so it will be e to the -2t, and then sine omega t, and omega is 1 here, so that will be simply sine of t. Okay, so what we just now got is this, that is L inverse, and I'm just verifying it by software. That is, as we had before, it's 2 times, and this guy is writing it on the right. Let's put that on the left. So e to the -2t sine t, and let's just go ahead and erase it all here, all this written portion. So what we have is that first of all, I mean, when we are writing it as 2 over this, and you know this here, since this is involved in the other ones as well, and you saw this is 2 times that because we noticed that this Laplace transform is e to the power negative 2t times sine t. Okay, so we have obtained this inverse Laplace transform. Now let's work on the other ones. Okay, so first let me erase this. Okay, all right, and then I'm going to bring the other ones down, and then we shall make the comparisons. Okay, let's bring the list of our formulae up here. Now, if we look at this one, let's look at the transforms that we have. We don't have this appearing anywhere so far. Now, let's just keep going. Bring it to the left a little. Okay. We still don't get that format yet. Okay. So if we go further down, you may see that, well, this is all the way to the end, but we are towards the, end of this chapter as well, that you may see this resembles this in the following sense that, let's see this here. That is, when we look at this, then e to the negative 2 pi s over s square plus 4s plus 5. This may be written as e to the negative 2 pi s times 1 over s square plus 4s plus 5. Okay, so this will be our first part right here, and this would be how much? Y. Okay, so if we are looking at the inverse Laplace transform of this, then what will happen? It's a product of 2 functions. The first one is, that comes from here, so that will be the Heaviside function. So here we get this portion here, so u sub pi t, you also write this as u t minus 2 pi. Feel free to write it any way you would like. So it's u sub 2 pi t, and then this will be derived from the inverse Laplace of this, and for inverse Laplace transform of this, you just saw that is given by how much? Or little yt is going to be e to the negative 2t times sine of t. Okay, but what we have is that we have to write y t minus alpha here. And who is alpha? Alpha is 2 pi, right? So that will be e to the negative 2, okay? And then t minus, what we will have here? 2 pi, and then sine of t minus 2 pi. And that is not going to matter because sine is a periodic function with period 2 pi, so that will become sine 2t anyways. So this would be what? This will be simply e to the negative 2, right? T minus 2 pi times sine of t. Okay, so our inverse transform will be, so the first factor is u to the, this Heaviside function, u2 pi t, and this second factor is going to be this quantity, e to the negative 2t. We're distributing negative 2 here, and then let me erase this here. So, and then next we have e to the negative 2t, and then negative 2 times negative 2 pi would be e to the positive 4 pi, and then we got sine of how much? T. Okay, so that's what the inverse Laplace transform of this function will be. When we go for this one over here, then what changes is this, that here this 2 will drop because we have only negative pi s. So alpha instead of 2 pi will simply be pi. So what we will have here also, we will simply have, pi here, and in here we will have sine of t minus pi. But so there will be one difference here, that is sine of t minus pi would not exactly be sine of t, but that would be how much? Negative sine t. There we had sine t because the period of sine is simply 2 pi, and here we had to reverse. Let me not stretch it too far. So that will be negative sine t from your knowledge of basic trigonometry. So if we are writing the inverse Laplace transform of this, so what that will be? That will be u pi t, right, instead of 2 pi, and then e to the power. Now remember this, that this negative, negative 2t remains as negative t. Only thing that changes is pi changes to negative pi. So that will be e to the negative 2t, and then when that distributes, this will this time be e to the 2 pi times sine of t, but then we will have a negative sign in front. So let's just go ahead and write that in our answer. So now I shall minimize this here, and so first I am writing this down, and then I would just, after writing it down, I'll just erase it. Okay, or who knows, let me just try getting it from here. Okay, so that's the same thing. This heavy side t minus 2 pi, I can bring it in front. That is that this is u sub 2 pi, all right, and then sine of t the way we wrote it, okay, and this was e to the 4 pi as we have here, and before that we wrote e to the how much? Negative 2 pi 2t. I'm just repeating myself too much. Okay, all right, and so this part is taken care of, and likewise we will have this portion. So why don't I erase this handwriting here first? So let me quickly do that. So because we know we got right answer, and we had to do this, we had to just match those values. It's a good exercise. That's why we are asked to do that by hand. Okay, so you have all this, okay, and then okay, so here we are almost done. Sorry about not doing it beforehand. Okay, so what we have is this will become how much? Again, this is negative. I'll just bring it over and make the changes because we know all that we have to do is just change those, okay? And this is out. All right, so here we go. This comes over here. Okay, so when we are writing our y, what our y will be, or what the solution will be, that will be the sum of we have this right here. So let's just write them in sequence, or let me bring this down here again so that we can write them in sequence, and many of you might have just shut me off anyways, and which is okay, because okay, so the first one is who? This is the first one, okay, and then we got right here the second one, okay, and then we got what? The third one. Okay, and so this is our final answer then, and we can do this if we would like. We can just go ahead and take e to the negative 2t sine t e to the negative 2t times sine t out as common, or let's put the sign on the other side. Okay, so what we will have is, yeah, I'm just doing this, sine t is out, and we'll just, so this whole thing is out. Then here we have sine t out, and here we got these guys out. I think there I wrote two of them by mistake. I'm so sorry, I forgot that we were erasing this here. Sorry about that. Okay, so this is outside here, so this is sine t and u to the, and over here this sine t is out and this guy is out. All right, so I think we have written it down correctly now. Okay, and if not, let me know. Okay, so thank you. Sorry for going so slow. Okay.